maybe
Right.
there's a way.
Fine.
Oh. And here we go. Even better. There was something to this. Hello, everyone. Welcome to the first meeting of the freshly minted IoT Operations Working Group at IETF 110. Alexei and I will be trying to be your useful co-chairs here in this space. And we have a very packed agenda for today. So let me quickly run through the chair slide here, which probably the most important part is the notewell. So as this is going to be a place where even new attendees might flock to, it's important to highlight that there is a notewell that's answering all your questions about IPR. So follow these links if you're not aware of that. It's also Googleable in the IETF website. If you're not familiar with this, please do get familiar. And also, this session is being recorded. Everything you say here will be part of this IETF. And yeah, again, there are some interesting things. Please, we have to get some note takers, and Alexei will do this in a second. This is the agenda. We are quite packed. We hoped for more open mic, actually, but I'm running through this quickly because I can spoiler that we are intending to do a virtual interim very, very short term next to this meeting here. And therefore, today you will basically get an insight in what topics are interesting in this space, and then we can have a discussion on that. So Alexei, please. With the note takers.
Yes, apologies. Yes, any volunteers for the scribe in the CodeMD, please?
I can.
Okay.
And can we get, sorry?
Thank you.
Okay, moving on to the first presentation. And I'm sorry that I have to switch this here. I think I have to restart sharing because there are multiple PDFs here on my system today. Huh.
This is Warren, and am I up first? If so, I can present. That way you don't need to get... Okay, let me present. Ask to share screen. Somebody has to click the button to grant me access. Yes. A Chrome tab, charter interpretation. There we go. Hopefully that's sharing correctly. So hi, everyone. As Henk said, we are fairly low on time, so I'm going to go through this really quickly. But I wanted to give people a quick introduction to the Iotops Charter, because this is somewhat of an unusual working group. So this is the Iotops Charter. Wow, that didn't work. There we go. It's really long, isn't it? It has many, many words in it. Here are some of them. So the Iotops working group is chartered for the discussion of operational issues related to IoT devices. For a long time, it's been really clear to us in the IETF that we need some sort of IoT-related working group. There's a huge amount of work that could be considered IoT-related. You know, this is done in ACE, Anima, Core, Drip, Roll, LPWAN, etc. But there isn't really a sort of overarching architecture. We've got all these building blocks, but there isn't really anything that says, if you take all of these building blocks and you want to actually build an IoT thing, this is how you do it. And so for the past many years, 6 or 7 at least, we've been talking about actually chartering something, but we kept running into the problem of we're not quite sure what area it should go in. We're not quite sure how to limit the scope. We're not quite sure how to make it actually all work. And this ended up the perfect being the enemy of the good. we couldn't actually get anything charted because we kept running into these issues. So after a while, we decided that we should just do something. And so this is the sort of initial first Iotops working group. Because of the problem of defining the scope and the problem of figuring out where exactly the work is going, we are trying something new. This is going to be a new concept in the IETF, and it's a discussion group. The idea is, instead of being a normal style working group, this is going to be a venue where people can come together and say, I took a little bit of stuff from ACE, I took some stuff from LP1, I took some stuff from Suit, and I mixed it all together, and it almost works, except that I can't figure out how to make this last little bit work. Or I have gone through and I have built and deployed my IoT architecture, but when I went to actually deploy it, I realized I had 1 million devices that are deployed now, and the actual operational aspects of managing this number of devices are really hard, or something similar. So as I said, this is a new style of working group. It's for discussion and for people to share information, but it's not likely to do that much actual document creation itself. The working group can do things like publish operational practices, and it can do things like document requirements. So for example, if people try and implement things using protocol X developed in the IETF and protocol Y developed in the IETF, and when we try and put them together, we realize what we're missing is something really important, which is Z. We can document these sorts of requirements and explain what the missing bits are. This working group is not very likely to actually create protocol Z. Instead, what will happen is we will most likely say that's best developed in existing working group, or potentially, there is no working group that is exactly perfect for this work. And so we might end up chartering new working groups, either in the ops area or in other areas. The other thing that this working group is likely to be good for is newcomers to the IETF, people who have already started developing an IoT ecosystem, are going to come along and say, the IETF has all of this work. I don't really know where my particular section fits in. Or, are you already working on this particular set of protocols or problems? And so Iotops is supposed to be a friendly, helpful way to introduce people to our work and where it's happening. As I've mentioned a number of times now, this is a new concept and new style of working group in the IETF. And it was, as you've probably realized, very difficult to get chartered. It took us a long time to try and actually get the charter created. And a fair bit of that is because it doesn't really fit into our existing structure. So what we're asking is, about 1 year after chartering, we're going to ask the chairs, in collaboration with the working group, to prepare a report for the IESG and IETF as a whole, explaining what the working group has managed to accomplish, but also how this idea of a discussion style working group works. Does this work well? Is it worth us having more discussion groups in other areas or on other topics? Rob and I obviously believe that this is a good concept and will work well, a way to build architectures from our building blocks, but that's still open to proof. So, as I mentioned, the chair said, keep this really short, so I'm keeping it really short. Questions for myself and or Rob? Many of them we're likely to have to do offline, but
totally. You understood, so just speak.
Yep. Yeah, A, thank you very much. B, I would suggest to the chairs to query feedback about the usefulness of the group, already, this week and every other time we meet, because that makes it a lot easier to track its success, because there'll typically be in each of the meeting different participants. So just to make all these knucklehead folks in Administrivia happy about, that this group is very useful, which I do completely agree with. Thirdly, to the point, so I think that requirements already is fairly far down the path of knowing how to solve things, right? So I would very much hope that something like problem statements, looking at use cases and how they don't work well, as a discussion starter would also be within scope, and that's a question.
Yep. Yeah. Maybe requirements wasn't quite perfect. Sort of gap analysis and similar might have been a better set of words. But yeah, you're right. Requirements is too far down the path.
Elliot?
Good morning, good afternoon, good evening. Thanks for taking my comment, and thank you, Warren, for setting this group up, and for Alexi, for you for supporting it, and a special thanks to Hank for agreeing to take on this task, which really is rather amorphous, as you pointed out, which has been a struggle. I was just going to answer a little bit to Torlis on that point, which is watch this space, because I actually have a contribution towards the end, which I think goes to exactly what Warren is looking for. It's not trying to solve a particular problem at this point in time. It's just highlighting a problem in terms of a potential architectural component in the picture that's missing in onboarding. But I don't want to get into the presentation. I'll just say watch this space, and if we don't have time for it, go read the draft.
Excellent. Well, I think I managed to keep it just under 10 minutes. Did want to just mention that 99% of this was actually Rob pushing and me sort of following along. And so he's actually the one who deserves the thanks. And back to you all.
Yeah, we have to cut the queue, unfortunately, Torres, to keep in time. But we can, again, there will be in the near future an interim here. I will now share the slides for the first presentation, which are not these slides, but this one. Is this visible? Lightweight M2M, is that shared now?
I can't see it. I only see your agenda slide.
Okay, then it does not change. So done. Alexei?
Or I can also present.
Oh, that is a blast. Thank you. I'm still trying to figuring out how Meet Echo prioritizes my tabs. Sorry for the.
Can you see my screen?
Yeah.
Okay.
Excellent. Thank you.
Yeah. My name is Hannes Trefinik, and I briefly wanted to talk about the work done in the OMA, Open Mobile Alliance, on the lightweight M2M, lightweight machine-to-machine protocol for IoT device management. Give you a brief overview very quickly only. So if you open the specifications, which are publicly available, and at the end of this slide deck listed as links, you will see that the architecture here shown in this yellow bubble consists of a lightweight M2M client, which resides in an IoT device, which then talks to two types of servers. A bootstrap server, which is a fancy name for key distribution server, and a lightweight M2M server, which does the rest of the IoT device management. But there's also obviously happening something outside that yellow box, which is the interaction with some application servers or apps or who knows what. And those are typically in deployments also found, of course, but are not covered in the specification itself. There are actually other standards organizations doing that type of work. Also not shown here, which I would like to point out, given some of the prior work in the IETF, is any type of provisioning of credentials for, or distribution of credentials for network access. because there are lots of different radio technologies out there, and they often have their own scheme. So this is really about distributing sort of or configuring.
Hannes, your slides are not advancing.
Okay, but can you see now?
You've
Just see the
shared
title slide.
a PowerPoint window and you've gone full screen on it, which is a different window.
Does it work now?
Yes.
Okay, I'll just stay with this. Hope you can still see. So this is the, I'm sorry, this is the slide deck I was just, or slide I was just showing with the architecture. And to describe these, so what is being described is a protocol, and there are different interfaces. And the one that is relevant to the discussion here on bootstrapping or the key distribution or security in particular is the so-called bootstrap interface, which works between the client and the bootstrap server. And it provisions credentials, configuration information about what server to talk to, and details of that configuration, communication interaction, and also access control lists. There are also other interfaces which are equally important and actually the main purpose of doing the device management, but they are less security relevant, I would argue. When we look at the protocol stack, and this is a figure of the stack of the latest version of the lightweight M2M specification, mentioning that there are, in the meanwhile, various different versions published. You can see that, first of all, there are lots of IETF protocols being used here, but also that there are lightweight M2M messaging, which is on the top, runs over different transports and can thereby then tailor to specific usage environments. So MBIoT is different than, let's say, Wi-Fi deployment, and MQTT is different than co-op, and lightweight M2M doesn't care that much in general about what's really done under the hood. But of course, as a specification developer, you need to describe those. In addition to what is shown in this diagram, there are lots of other IETF specifications being used, and I listed some of them on the bottom of the slide. Of course, many of the co-op extensions, but also security specifications and sort of the encoding mechanisms that the IETF has been working on, like CBOR, NML, etc. When it comes to the security aspects, one important piece is sort of this, what the specification refers as bootstrapping, or some people call it enrollment, key distribution, you name it, is that a device, the lightweight M2M client in the IET device needs to talk to the server side, the lightweight M2M server, and in order to do so securely, either using DLS, DTLS, OSCore, or a combination even of those, sort of OSCore on top of DLS or DTLS, it needs to have the credentials, it needs to have the configuration, it needs to potentially have access control lists. And there's obviously the question of where this comes from. And one possibility is to provision this straight into the device during manufacturing. But this is less practical because you already need to know a lot of that information up front. And so to make this process simpler, this bootstrapping mechanism was introduced, which allows the bootstrap server to send this information to the lightweight M2M client so that it can then talk to these different servers and to send sensor data and who knows what to those servers. That's what we call bootstrapping. There are different forms, obviously, from a security point of view. And I believe the most important ones are whether the keys are generated on the server side or whether they are generated on the client side. And the specification supports both, also with different types of credentials, symmetric keys, raw public keys, and certificates. And my favorite, obviously, is to generate the keys on the device side and to never have the private key leave the device. And this is accomplished using the enrollment of a secure transport specification, which, as you know, is an IETF document. There's a flow in there which sort of details one of those exchanges graphically, but I will skip it for the benefit of time. And instead would like to talk about the data model, which I think is also very important for getting this whole thing work. And this relates to another recently created IETF working group, the ASDF group, to which some of our members contributed to, or are still contributing to, which is the data model. Because you need to have a way, when you provision information to a device, you need to have a notion of what are you provisioning and how does this whole hierarchy look like. And the data model, like with the M2M uses, is very simple, and it's actually shown on the first line, where you access objects and resources in a sort of like RESTful style. And so a device can have multiple objects, and objects have resources which contain parameters, essentially. And there are several of them specified in the lightweight M2M specification, which are shown on the screen. The most important one for this discussion is probably the security object, which contains all these different keys and parameters that are being provisioned. But also the others are obviously important as well, knowing which server you should be talking to, who is allowed to access certain information, etc. And if you go to one of the links at the end of the slide deck, you will see that there's a registry with several hundred objects being registered, doing all sorts of things from a water meter to a gas meter, street lighting, everything. This work has been around for a little while already, so there are 9 test fests took place, and the next one will be in 2 weeks. There at test fest we have counted more than 40 implementations, and you can implement and run this and deploy it on a very small device. So 64 kilobyte flash, 16 kilobyte of RAM is a possible scenario for full-blown implementation. As I mentioned, is around for a little while and still work in progress with new versions and adding new features. So 7 years of development time, and we have a quite active developer community. So there's a public GitHub repository where developers can discuss and raise issues. There's also a list of popular open source implementations that we collected and put here on this wiki. And here's the link to this GitHub repository that I mentioned a second ago. If you care about looking at the specifications, here are the different versions. Version 1, sort of 1.0, 1.1, 1.2 is the latest one, which was published end of last year. And there are all sorts of additional documents, extra features that were published on the site, which you can find on the other link. And the last link is to the object repository, which really make the whole thing complete, because you need to have a description of the sensors, actuators, configuration information, and so on. So to manage a device over its life cycle. And that's all I have. And if you are interested in any of the details and get lost in the specifications, just drop me an email. Thank you.
Do we have time for a quick question?
Yes.
So very briefly, Hannes, thanks for this. So I have been reading the specs myself, trying to summarize the bootstrapping. My question is not related to bootstrapping, but to the concept of ACLs, or the access control lists. Is there anything that the OMA specs have to say about like the work done in ACE or OAuth, or is that like then completely left out, and if like, is there some relation to the ACLs?
So the relationship, so OAuth and ACE would be a dynamic model for managing access to IoT devices, typically involving also humans, like users, let's say a technician trying to access a device. And that's something that the lightweight M2M specification didn't do, partially knowing that there is this work in the IETF on this specific case. And so there is not much overlap in that regard. So the lightweight M2M specification doesn't talk about permissions of users and sort of more complicated scenarios that are addressed by lightweight M2M.
Yep,
Yeah,
thanks.
there's a mistake in this on this page. So the lightweight M2M 1.2 was published in November 2020, not 2003, not 2002. That would be going back in time.
Thanks, Hannes. Thank you a lot. So the interesting to this would be, of course, to see what do you want to have, what do you want to see here incorporated as ongoing work for this working group. So maybe we can take this offline and we can discuss a little bit how this feeds.
I could so for us in general, it has been extremely important to maintain a sort of a lively exchange with the IETF community, because we have so many dependencies on IETF specifications, and so there's we would appreciate a better flow of information back and forth between the groups, and also understanding better how some of the specification evolve, so that we can properly make use of them.
Thanks, Hannes. And I think that's a good segue to Geoffrey. Hi, Geoffrey.
Hi.
It's your floor.
Okay, thank you. So this is Jeff Cooper, and I'm here from Intel Corporation, but also from the FIDO organization, FIDO Alliance, and I wanted to talk about FIDO Device Onboard. So FIDO Device Onboard, let's see if I can figure out how to, there we go. Okay, so the FIDO Alliance, about a year and a half ago, we got together and decided to set up an internet an IoT organization, and you can see that we brought in sort of an interesting group of people, which had a lot of CSPs, a lot of chip companies. We developed requirements. We figured out that we wanted to fast track the development, so we would pick one target. We chose SDO, Secure Device Onboard from Intel. Let me see if I think I don't need the video anymore. So, so we decided we would choose Secure Device Onboard. We allowed for some modifications of it, taking in some newer protocols, CBOR, etc. And we got to a review draft, and you can see some characters. For example, Hannes, who just spoke. And we have a URL, and you can take a look at it. And we're actually getting fairly close to a draft standard release of this protocol. And let's see if I can still move forward. And in addition to that, we have an LF Edge project, which happens to still be called Secure Device Onboard, and eventually it'll change its name, which is actually working on implementations of this protocol. And if you go to their GitHub, you'll actually be able to see first implementations based on the review draft, and you'll be able to go and download them and implement them and try them out. And there are full implementations of the protocol that are underway and will be available relatively soon, in a few months. So what is it? So we had this thing that we said, well, IoT is slowing down because we're not getting the devices onboarded fast enough. So what if we just pay attention to onboarding? So whereas Hannes was talking about an entire data model and a management of IoT, we're talking about the very first few seconds of the device, from the box opening up to getting the device on board in full service. And we wanted that to be the customer value prop, that you drop zip the device to one location, that you press essentially one button to power up and connect, and I'm glossing over the network. And then the device is on board, and everything about that device that needs to be done, all of the applications, all of the sensor connectors, all of the trust models, everything is set up, and the device is in service right away. And so that's what we mean by saying we're going to try to solve the problem of onboarding. We want it to be fast, scalable, and secure, and we want it to be device provisioning, onboarding, and activation. And you can do a cross product of those things and figure out how they all fit together. So there's a concept that we came up with, which was a late binding concept. I think that's a really important piece. That's the one that I want to sort of talk a little bit about here. So if you think about the thing that slows down IoT in this onboarding process, it's that you have manufacturers who are doing this build to order kind of mechanism, kind of like the old days. Am I not? Okay, reconnecting screen, share. Okay. You have manufacturers who are in this old-fashioned build-to-order kind of mechanism because we have the same device going out for different ecosystems of IoT. Different customers have different ecosystems. If, you know, in the days when you were allowed to walk into Best Buy in the United States, you would walk into Best Buy and you would see 3 different tables, one for people who do, you know, one kind of IoT vendor, another who do another kind of IoT vendor. And you have to choose which table you buy your devices from, but they could be the same devices. So what we want to do is we want to have a build to plan. So we want to be able to make a single SKU. And when the devices get on board at the end of the supply chain, we want to figure out which IoT platform they're going to go onto. We want to figure out what needs to change in the device to make that IoT platform happen. We need to download all the credentials and perhaps activate software to make that work. And that's what late binding is, and that's what FIDO Device Onboard does for you. So let me talk a little bit about how it goes. We don't have a lot of time. So there's a credentials put in the manufacturing process. The device is put into a box and is sent to its dropship location. And the goal is that you don't have to open up the box again. So the fact that it's a closed box is important, right? And it's closed until you're ready to power it on. There's a data structure that's created called the ownership voucher. And this thing is sent along through the supply chain. Sorry, guys, frog in my throat. It's sent along through the supply chain to the target. I'm saying cloud, but it works in a closed network. So, you know, it's the IoT system, the device management system, the IoT platform. It's sent along to the target where you're going to manage the device from. And then the device is now ready to be turned on. The target cloud, the device has this problem. The device needs to know, because we're doing late binding, it doesn't actually know who's going to onboard it. So what it has is it has this middleman here, a rendezvous service. Rendezvous service works very similar to DNS, and I'll tell you, if we get a chance, I'll tell you why we didn't do DNS. But this is an application server. When the target cloud gets the credentials for the device, it registers its IP address with the rendezvous service. The device has the same rendezvous service information configured in it, goes to the rendezvous service, and gets the IP address of the target cloud. So that's who is going to be my manager. And then how they're going to manage me, how they're going to authenticate, that's all done over this last piece. And the way that works is that the ownership voucher itself is used to authenticate the target cloud. So there's a new object added into the chain here, which makes it possible to late bind the identity of the target cloud. And the device authenticates in a more conventional way using its device certificate. So then you do two-way provisioning. Now, the important thing is that we're not done yet. The important thing is that you need to go into a mode where you can provision all of those things that you would like to have the device do. And so there's a data model that comes up here that's sort of a general purpose data model that allows you to do additional provisioning on top of this connection that you set up. And you could do, for example, you could at that point adopt a data model similar to what Hannes was doing and send those objects down if that's what you want to do with the device. Or if you had a more general purpose device, you might send down a capsule and send down a script. And you have a lot of flexibility, and you can then attach the device to as many trust roots as you need. You can do CSRs, you can do whatever you need to do to turn on the device. So there's a mini little language that you can use to actually communicate with the device back and forth until you've got the device in its final state. And then at that point, you complete the protocol, and the device goes to doing what it would always have done if you had done a manual onboarding process. And all of this stuff that I showed you goes to sleep, and it only appears if you ever need to use it again. And that's the story of this onboarding. So I wanted to sort of emphasize a little bit, what can you do with it? You can set up all these things, right? You can set up multiple credentials. You can set up credentials inside of a T. You can set up application credentials. You can download hardening for the OS and for the firewall, etc. You can set up other IoT devices. You can use this as a server to set up to run FDO on other devices. And you can do that over the internet. You can do it over the intranet, and you can do it over a closed network. So that's the story I wanted to tell you today. This is something that's coming to a GitHub near you. You're welcome to use it. You're welcome to come and participate with us in it, and I'm happy to answer questions. Any questions?
So as a chair, of course, hi Jeff, I could again ask the question. I feel that there's a lot of overlap in the general direction here, and also a lot of discrepancy in the details. How do you see this, for example, when you take into account Hannes's presentation beforehand, how this requires alignment, and how do you expect to find some support here in this space?
So we thought about whether we should stop early, and basically, in other words, we should stop early in the protocol and say, well, at this point, if you're LWM2M or your Azure or your some other CSP, you will have protocols that know how to do all these things. So why don't you just do what you need to do? And we felt there was an impedance matching step that was missing. And the problem is that if you actually want to say that you have a device and it's going to go to any cloud, any device manager, you need to have some place where you can do a little bit of massaging of the device. So the way we do it is, the minimum you would do, for example, is you could use the onboarding of FDO to hook into the onboarding that you used for your solution specific mechanism. So for example, one of the things we have done is we have used the FDO onboarding to provision lightweight M2M credentials, then reduce to previous case. And then on the other hand, if you wanted to take a bare machine and put a very lightweight operating environment on it, we've actually used it to install the entire operating system to bring up a container environment and to run an application. So we wanted to give people the opportunity to say, well, when you arrive at the destination has the ability to tailor the device. This is actually what we mean by late binding. And we think this ability to do as little or as much as you want to do at that point is actually necessary. But we are not trying to manage the device from this. In other words, if you have a strong device management system, do less in this phase. If you have less of a device management system, or you need more of accommodation in the device before you start, then do more in this phase.
Yeah, I see. There's an agile but somehow deterministic still path forward here when your device hits the premise, it's the CPU premise, basically. Okay, that sounds smart. Alexei?
Ash, we have time for a couple of more questions. Ash, please.
Hi, thanks. So I have a quick question about the rendezvous service. And you mentioned that you specifically didn't use DNS for that. And I'm curious about sort of the design decisions that led you there.
So it's been one of those things that we've had to sort of think about over the years on this. So the problem that we had is that in a lot of organizations, the owner, remember, we're thinking about different kinds of networks, right? So we're thinking about, say, corporate networks and internet and closed networks. Often the entity that is managing the IoT is not the entity that's managing the DNS. And we have this situation where you have a server that's receiving a credential and it needs to register itself and with some kind of a lookup service. And in a lot of organizations, that's a big problem. And so we said, well, it's actually easy in organizations for an IoT organization to bring up an application server. That's what they do. So if we put the information in an application server, we figured out that we can make it happen automatically and reasonably. So one of the things that the FIDO Alliance did is they did actually put in a breakout mechanism. So if you already have some kind of a lookout mechanism, you could use that instead of the rendezvous. But the rendezvous is the service is the primary mechanism, and it's not a big server. It's a little server.
Okay, cool. Thanks.
Very quickly, Dan.
Yeah, thanks, Dan Harkins. Can you tell me? You said the ownership voucher is a data structure. What's in this data structure? I guess there's probably a cert and maybe an identifier of the rendezvous service. What else does the manufacturer have to decide
So the
upon?
manufacturers, sure. So there's a manufacturer certificate information, manufacturer's key. There's a device key in there, so you can authenticate the device. And then basically what's happening is as the device moves through, as the ownership voucher moves through the supply chain, you can build up a chain of signatures that shows a ledger of where the device has been. And you can use that ledger to show that you're actually the guy at the end of the chain and you got the last piece of it. So it's a new kind of a tracking data structure. If you had, say, a reliable supply chain, you probably would already have this kind of mechanism. Since the world doesn't have reliable supply chains yet, we wanted to have a mechanism that could run through a conventional supply chain with minimal types of verification, say, all the way down to, say, telephone level of reading out information about a key. So that's what it is, and there's information in this presentation, so please go ahead and look at the extra slides.
Okay, yeah, thank you very much.
If I can figure out how to stop presenting, I will be happy to do so. There we go.
So next up is Elliot. Elliot, do you want to share your slides yourself? And that's a yes. I thought. There they are. It's your floor, but you're not.
I appreciate it again, Hank. Let me just get to the start. I was just having some deep thoughts in the architecture, and I've been thinking about this problem for a while, as both Jeff and Dan know, and of course Hannes. So we're all well familiar with each other. We have this sort of general question that we hang out with. We all answer it slightly differently. I'm going to talk about the tale of two protocols in this context. I'm not trying to favor one over the other. I'm just saying that there are some challenges that we face, and they're slightly different challenges, but there are some architectural components that I just wanted to note. And the questions, how does a device know it should trust a particular network, and how does a network know a particular device is authorized? Two different protocols try to answer this question in two different ways, DPP and Brewski. And if I were to take a stick to it and just whack it just so, I'm pretty sure I could get FDO in the same bucket. I'm not quite sure about LWM to M if I could do that. Just as a bit of a review, because I think a lot of people on the call know these protocols. DPP is the device provisioning protocol the Wi-Fi Alliance did. Dan was intimately involved in that. A lot of other people were too. The basic concept is, you have a public key that is associated to a private key. The public key appears, say, in the box. You have a device that scans the box. It scans the public key, and then it does a little bit of a Diffie-Hellman proof. It says, hey, I've got your public key, and and here's my proof. And this guy says, well, I've got the private key. Here's my proof. And the next step is a configuration phase based on that. and then this guy gives this guy what it needs to talk to this guy. A version of that we have from Brewski is slightly different. It works with a voucher. The voucher gets passed through. It says, here, can I please talk to this network? This guy is going to ask this guy if this guy can authorize this guy to talk to this guy. This is essentially what Brewski says, and it does so with a voucher. So you have this flow, and the voucher bits get filled out. And what you get in this guy is a trust anchor, which this guy can then use to do things like EST. We have a couple of scaling problems throughout all this, which is one of which, in the Brewski context, how does this registrar know the various enterprises, right? Because there are gazillions of them, and conversely, how does this manufacturer know that this enterprise is the one that actually bought the product? Just a little bit by way of a comparison, right? What I'm aiming for here is zero-step provisioning. DPP on its own, using a QR code, provides a sort of nice one-step provisioning mechanism. You can get to zero-step, right? I think, but it's a little bit of a challenge as to how to do that, right? It's a question to be answered, and it can work with or without internet connectivity in the moment. In fact, forever. Which is a really nice property. It doesn't really have a concept of ownership per se. It has a concept of possession, which is really nice too, because it means if you just reset the device, you created a change of ownership. That's sort of nice. So in the Brewski sense, on the other hand, this thing can be zero-step provisioning if you filled in all the gaps in terms of understanding who the customer is and the associated registrar is with it. It requires internet connectivity, at least in the use case that was envisioned, though there have been some thoughts about how to relax that. If you look inside a Brewski voucher, it has this notion of a nonce, right? And that nonce is, if it's filled in there, then you have to have an interactive exchange. If it's not, then you don't. And this question here was left empty by the specification, right? How is it that you there's this notion of a proxy registrar, a proxy voucher request, but how can we get more formal in terms of associating this registrar with this customer, right? And then how do you manage to onboard the device without immediate internet access? How do we get around that nonce problem? So my last slide, okay, the 8366 voucher and the DPP key are actually much closer in style if we think about zero touch than one might first appear. There seems to me that there is a missing architectural element, though, which is this introduction that needs to occur between the device that's going to hold the keys. In the DPP case, you might think of that device as this guy here or an agent for that guy. In a big enterprise, you're probably not going to have every AP try and manage all keys, right? And you're not going to have some guy just trying to onboard each device, with an app. There's going to be something more there, right? So you have something that akins to some sort of AAA function that also is speaking, the DPP protocol, and the DPP standard allows for that. Well, that looks an awful lot like a registrar as things begin to grow, right? And the question then, for me, is quite simply this: how do we make this general introduction between these manufacturers and these registrars? Now, federations do this nicely, right? Which is nice, but it's also nice that these federations be optional, right? That is to say, one of the challenges I think we see with Brewski is that you have a lot of mechanism here to and from the manufacturer. I see a lot of that mechanism in FDO as well. It has its pluses and it has its minuses. And if I were to add FDO to this mix, I'd say one of the nice things about FDO is that essentially you get a nice sort of, where this thing has been a certificate. But the open question here, right, is how might we go about establishing the trusted introduction between all these guys, just these guys, not the devices themselves, these guys, right, the enterprises, right, maybe even consumers too, if we want to stretch that, but as I have enterprise on the brain, that's what I filled out here, and these guys, the manufacturers. And so that's the open question that I have. It's a problem statement. I'm not going to answer it today, but I think it's a problem worth solving, and I am going to work on solving it a little bit. And I'm not particularly fussed about which of these onboarding mechanisms we solve it for first, so long as we can have a little bit of choice in the process, because these guys are going to implement whatever these guys are going to implement, and as long as we have some notion of consistency in this federation element, or whatever it is, in terms of how information gets propagated and introduced, if we have the right model, then we can implement a couple of these things, including perhaps even FDO. And that's something we might want to talk to the FIDO Alliance people, specifically Jeff and others, about if this makes sense for them too. And maybe Hannes has thoughts in terms of LWM to M in this context. And of course, what I'm talking about here is network onboarding. I'm not really talking about application level onboarding. So how do you get the thing on the network? And I'll stop there. Questions, comments, or should I just leave it to the next guy?
So this is Hank. Maybe on the group. I can say that I'm a huge fan of problem statements, and I think it's very spot on to the charter. So thank you a lot for that. I think fleshing that out in a document would be a very good first step. So are there any other questions on Elliot's or comments on Elliot's item? And Jeff is going, I think.
Yeah, yes, I was thinking that one of the things, I agree that you do have to get objects through the supply chain, and one of the ways that's going to be challenging is that the supply chain is so enormous. So one of the ways to think about that is think about what objects could be secured going into a group of companies that have a single agreement for shipping devices, shipping objects in the supply chain, and then how you would get an object out of that and into the next one. So I'm thinking that we can put together a few cooperating companies and then get objects into them, get objects out of them, and then go to the next group and the next group and the next group. So that may be a way to think of the problem.
Very good. Thank you. I'll be in touch with you to ask about that a little bit more. And thanks for the time, Hank.
Yeah, and thank you for presenting. Michael, are you commenting or sharing for your presentation? Sharing.
Share.
Then it's your floor.
Yes, I want to share that. I will comment that the 8366 voucher, we really wanted to be much more SDO-like in its supply chain integration. And in 2014, when we started on it, it was clear that no one was ready. And I think that's still the case. So I'd be excited to be proven wrong. So in doing some of this onboarding work, one of the problems that one runs into is how do you get initial device identifiers into devices? And one project I've been involved in is doing this for home routers. And click, just a minute. Oh, okay. So, insert the Mirai story. That's actually coming up to 5 years ago. It's kind of weird that that's so long ago, but I've been involved in dealing with how do we do security, specifically MUD stuff, for instance, on home routers, and how do we onboard home routers so that they stay secure. The whole admin and min password is simply not good enough, and making people change it is a great thing, but then you just wind up with the problem of they now have a strong password, which some malware on their home network can hijack. And if you think that's hard to do, the answer is that ARP spoofing of 192.168.1.1 is trivial, and there's a number of second router products that offer some kind of additional security that intentionally exploit that to get into the data path. And that's just there. So even if you say I'm going to put a better password, you still have the problem that you need to enable HTTPS somehow. Why can't I just page down? There we go. So you wind up with these two environments for talking to, for instance, your home router, but also to pretty much any other IoT device in your home network that you have purchased off the thing. And one is that you wind up there implicitly insecure. It's HTTP and you're just done, but apparently the web page loads. Or it's explicitly insecure and you have to click through these things, which to the most extent, the browser manufacturers would like to remove these screens completely if they could. And the last thing we really want to do is train any of the users to actually be good at getting through these screens. That's really the goal, is that they never ever see them. So the question is, how can we put a real certificate in there? And so we came up with this mechanism. And what it is that before the device leaves the factory, in effect, we want to boot it up and we want to do a provisioning step. And this process involves essentially finding a provisioning server over an IPv6 link local address that avoids us having to run DHCP and a whole bunch of stuff, but also really make sure that the device is really the device that's on the table there, and eliminates some other security and other issues. And then we do what is essentially an EST enrollment, except we can't use EST literally because we need a whole bunch of other data that doesn't fit into a CSR, for instance. And in this case, what we do is we exploit the fact that home routers will generate an IPv6 link, ULA address, which is a relatively unique IPv6 address. And we give them a name within the manufacturer's DNS zone. And we do a Let's Encrypt enrollment, and with a DNS01 challenge to DNS, and then we return the resulting certificate to the device. There's running code for this. In fact, I believe I'm speaking to you through a router that was onboarded this way. And the certificate winds up in the router, and you can talk to it that way. So what happens, so then we do something interesting. We populate the public DNS of the manufacturer with this ULA address. In this case, this is FDD4. You see that address, ::1. And we give it that name. And so this means that now there is a name that is attached to the, an IP address, which is attached to the name that is in the certificate. And when I pull up my browser and I point my browser at this router, by name, I have connectivity to it, and I load the certificate, and lo and behold, I have a secure connection. So that's this slide, and this is what happens. So we have had a little bit of challenges with this there, and it turns out that, for instance, what if you're not on the internet when you get connected? Well, the answer is most of the home routers will answer DNS requests for names they find in etc hosts, and so you need to populate that as well into there, and then you have a solution where you actually connect and it works without a problem. On Friday, Ted Lemon will be talking about stub networks, and this actually can work very well for devices connected by stub networks as well. The key thing is that you have to have that ULA that you control, and you have to be able to put it uniquely into a name that you control. There are some issues. The major one is with a Let's Encrypt certificate is that it expires after 90 days. And so if you put your devices from the manufacturing plant and you put them in a warehouse and they sit there for more than 90 days, then when they come out, they have an expired certificate. So we need to do something about that. And exactly what that is unclear. If we could just assume that there was internet connectivity for the device when they turn on, then we could simply talk to the provisioning server again and essentially wind up with a renewed certificate using the old certificate as proof of possession of that private key. But what if the device needs human intervention to get online? For instance, many home routers in a DSL kind of space need a PPPoE username password to be connected. So that causes a chicken and egg situation. You need to log into the device to provide that, and then you need the certificate to be able to log in, and what are you going to do? If you are an ISP and you're doing this and you're deploying things, then you can actually pre-provision some of those username passwords so the device can actually get online and can do things. Now, the reason we don't use a private CA is that we want it to be accessible from the browser, and that would not be accessible if it was a private CA. So the typical situation that happens in, for instance, with cable modems, which all have IDEV IDs built in, is that those are not connected to the public web PKI, and you can't manage them directly with your browser. The second problem we had was that we discovered that quite a number of systems are unwilling to do IPv6 DNS lookups or communications if they can't detect that IPv6 is live. So if you have a scenario where you don't have internet connectivity or you aren't allowed to do it yet, then these devices will say there's no such name, even though you do a dig or other, command line type things, and sure and hold, that's there. But these systems essentially refuse to do IPv6 if they think that there isn't any good IPv6. And this is, I think, a existential challenge to using IPv6 and ULAs in the world. We've seen this with a number of browsers and a number of systems, but it's predominant with Chrome. But we believe we've also seen it at times with the Edge browser, but it's unclear and unconfirmed. We have worked around this by essentially putting a v4 address in the etc hosts on the device, and then everything happens over v4. And that's kind of an icky hack, but it did work. This is there's some additional work that needs to happen. I'd love to have some more co-authors, and there's some overlap and some discussion that we might have as to how this relates to Danish, because we are using DNS, but we aren't really putting the certificate in the DNS. But that's a potential additional thing, but it wouldn't be very useful if browsers wouldn't support it. That's all I had to say about this, and 1 minute over.
Yeah, only 1 minute over. Thank you, Michael, for throwing out a tangible problem here. I think people are actually interested. The chat indicates already interest. So thank you for that. I'm very sorry that we are basically already at the bottom of the hour and the session is officially over. But yet, I would like to ask to maybe if people can attend this room for a few more minutes, we can throw out an ask. Which is about would you like to attend a in near time happening virtual interim, which actually will provide more floor podium from open mic and discussion, and picks up on the items discussed here, and maybe some of the gaps, maybe some of the things you thought would be here that are not, or some first ones on the items actually here right now. So what I would like to do is to issue a raise hand thingy here that we have in this tool, and if you raise your hand, it's basically 2 hums at once. So if you raise your hand, that's the first hum. You are basically humming for, yeah, I'd like to do that. And if you do not raise your hand actively, that's an option. I think it's a weird option, but still it's there. So we're using that as a second hum in one question. To basically, now you really don't want to see something like very early on in virtual interim to make time for that. So I will start that right now. And I would be very happy if you all raise or not raise, actually, your hand. So we're talking about, like, the question says it, spells it out, like 4 weeks or something in the future. And while we do that poll, there are people on the mic, and we can parallelize this as IETF wants to do. Eric.
Oh, sorry, maybe this is me not knowing how to operate things, but I think that's,
okay.
But I was actually going to make a comment earlier, but I think we're out of time, so I can do that on a mailing list.
Okay, thank you a lot. But again, parallelization, while we wait for votes coming in, I will give a little more like the 10 seconds still to this thing. And quick spoiler, the results are kind of obvious. Oh, I think you also see the intermediate results, right? Oh, there's one. Good. This proves this is a real poll. And here you go. So yeah, we will issue a corresponding proposal to the list. Alex and I will come up with a date that seems to be suitable, and then you can tell us why it's not, or agree. Thanks all for attending. And again, we will provide you with more mic time next time. And hope to get this started. Have a nice IETF. Not in Prague.
Thank you.